Thank you so much for joining in our 2025 Snag and Learn webinar series. Today we will be talking about advanced stormwater treatment. I want to remind you that you can drop your questions in the question box during the presentation. At the end, our expert will address them. Also, you can find a copy of this presentation in a PDF format in the handout box or material box. So thank you so much for joining, and I'll give the floor to Søren. Thank you.
Thank you, and thank you for joining. I'm Søren Gabriel. I'm with WSP in Denmark in Department of Climate and Urban Development, and I'm Head of Development within Climate and Sustainability. Over the last 3 years, we've been working intensively on stormwater and stormwater quality, especially chemical quality in stormwater, and that's due to new administrative regulation based on the EU Water Framework Directive. Some 2 weeks ago, my colleague Anja had a presentation about characterization of stormwater and regulatory changes. And it's, as my presentation, it's a part of work we've been doing for a governmental office in Denmark. It's not official yet, the project, but we are allowed to tell about it here. And just to go through her conclusions as the beginning of my presentation, I'll say that one of our points is that all stakeholders should try to meet EU requirements to achieve good quality in the recipients. And that takes that we treat our stormwater or by some other means reduce the pollutant load from our stormwater systems. We have identified a lot of different substances across different catchment areas. But the problem is that we have insufficient knowledge about quite a few substances that includes, for instance, tire chemicals, where we know that some of the chemicals have effects in the recipients, severe effects, but we don't know the concentrations yet in the recipients. We have defined 5 different catchment types and seen and looked into the stormwater quality in these catchment types. And what we can see is that none of the catchments actually has stormwater qualities that doesn't exceed the environmental quality standards set by EU. So maintaining and making valid data for inflow and discharge of stormwater of chemical substances in stormwater is important for our work. I'll come back to that later on. In the bottom here, there's a link for Anja's presentation, and I can only recommend you to see it. And then I'll start with a disclaimer, because working with stormwater is working with uncertainty, especially when it comes to quality. This graph on the left shows the concentration of copper on the x-axis and the percentage of data on a lot of data sets in the same minor Danish village. And as you can see, there's quite a distribution of the data, and there's a zoom in on the part of the graph. And that's the case when we're working with stormwater, that depending on when you take the sample, you'll have very different concentrations in, even at the same catchment, very different concentrations on different substances. When it comes to treatment, we have the same uncertainty here. On your left, you have a graph showing different treatment facilities, and they're marked with dots and lines, and then the concentration of the substrate on the x-axis and the removal rate, the removal efficiency on the other axis. And as you can see, depending of the technology, you have different effects of removal, but again, depending on the concentration in the inlet, you have different effect of removal. And that's a typical picture that the lower the concentration, the lower the removal rate would be. When it comes to treatment efficiency, it depends, of course, on the substance and on the treatment technology, but it depends on distribution between dissolved and particulate fraction, inlet concentration, as you can see in the graph, and then the treatment technology, and a lot of other factors like temperature, pH value, biological activity, etc. So just putting a removal rate is fully as hard as putting a fixed concentration on stormwater from a typical catchment. But we've done it anyway because that was part of our work. So we've been working with more than 200 substances which are included in the EU environmental quality standards, and we've split it up to 5 different areas or catchment types, like dense urban areas, open urban areas, and then a new type which are new developed urban areas where we don't use zinc and copper in roofing materials and downpipes and gutters, because that tends to make a lot of pollution. And then industrial areas and major roads. And we base this on the International Stormwater Database, on StormTag. I'll come back to that later on. And then on a Danish database called Regnvandskvalitet og Klimatilpasning. I'll talk about them briefly. The stormwater BMP, you might be aware of it. It was established some 25 years ago in a collaboration between different organizations and universities. And since they've collected data and updated the database. And you can go into the database and see urban runoff qualities and efficiency of urban stormwater BMPs from a lot of different field studies. If you don't know it, I'll suggest that you look into it. There was a link to it on the last slide. StormTag might be less well known. It's a Swedish tool which is like the standard. If you want to make stormwater discharge in Sweden, you have to make an assessment based on StormTag. It's made from a PhD study from back in the 90s, and this guy he has, with his company, been working on StormTag ever since then. So they've made a database of substance content in stormwater and split it up to a lot of different catchment types, and then they've been looking into treatment efficiency and different treatment methods. And one of the strong things about this database is that you can go into the references and see the underlying publications. And there's a calculating tool in the StormTag tool. The databases are available for free, but if you want to use the calculator, you have to pay for that. And with that calculator, you can characterize your catchment on natural areas, agricultural areas, and different urban catchment. And you can put on treatment solutions and annual precipitation. You can make treatment trains and different treatment solutions, and then you'll receive resulting substance load on concentration and annual quantities. And then there's a reporting module. It's not that common to use it in Denmark, but we're trying to get it introduced in Denmark, because that is, from my point of view, the best available tool for this purpose. They have a lot of treatment facilities like wet pond and different sedimentation solutions. They've got biofilters, different kind of biofilters with treatment through infiltration. They've got like permanent pavers, for instance, and they've got swales and ditches, which are transportation structures for stormwater, where some water might infiltrate, but the water will be treated on their way through the ditch or through the swale, so there'll be a treatment efficiency as well. And then, of course, dry ponds, which are similar to wet ponds, but with a lower treatment efficiency. And then for this Danish database, which is only available in Danish, but I would say it's quite easy to use, even if for a non-Danish speaker. It's an Excel-based database and a tool where you can calculate stormwater concentration and pollutant load from different catchments. And it's based uniquely on available Danish data delivered by municipalities and utility companies. Until now, we've got 68 indicator parameters, that's different substances. And until last year, it was primarily single samples of stormwater, but now they're working a lot with flow proportional stormwater samples. And it's updated continuously, so a year from now, it'll be a lot better than it is today. So based on that, we made this report on stormwater quality from different catchments. But what we found out was it can make a difference how old the data are. And there are different explanations for that. One is that lead in petrol was banned in '94 in EU. PAH in tires was banned in 2010. Copper was introduced in brake shoes to substitute other substances, and now since '98 it has been reduced from 10% in the brake shoes to 0.5% in 2025, reducing the copper load in stormwater. Then catalysts were introduced in the 90s, and particulate filters came in 2010 that was reducing VOCs and PAH. And then we had requirement for wood burning stoves, which actually contributes with quite a lot of PAH in some catchments. Electric cars, which are quite common in the Nordic countries, have zero emission from the engine, and they reduce brake dust by 80 to 85%. But on the other hand, we have increased tire wear, which we're looking into now. But tire wear and tire particles is quite new when it comes to assessing stormwater quality. And then there'll be EU requirement for brake dust from 2026 and for tire wear from 2028. So things are getting better. And if we look into the analysis, we can see that if we have new analysis from after 2020, there's in general lower concentrations than if we look into meta studies containing a lot of older data. When it comes to treatment technologies for stormwater, we have to split into purification mechanisms and technologies. The purification mechanisms would be sedimentation, like for instance in sedimentation ponds. It could be mechanical filtration. It could be sorption filtration, where you can sorb solute pollutants. You could have chemical precipitation, like on chemical wastewater treatment plants. You could have degradation of pollution, biological uptake, and evaporation of, for instance, VOCs. And when we've assessed treatment facilities based on these mechanisms, we have used StormTAC, and we've used Stormwater BMP. We've used some Danish assessments of best available technology treatments, mostly sedimentation pond and some filter types. And then we've been working on advanced purification with chemical precipitation with aluminum in stormwater and limestone sorption filters. And I'll talk briefly about them and our results. But first, wet ponds. I think that's the most common treatment facility for stormwater. The idea is you have got a permanent wet volume, and when you have the stormwater flowing into the volume, you'll have a sedimentation of the particulate matter. You can see there are some pros and cons. The good thing about ponds like this is it's easily combined with a detention volume if you have a limit on your hydraulic load for your recipients. It's a simple and low maintenance solution, which is cheap to establish. It has a high hydraulic capacity because you can have whichever inflow you want, and then you have this detention volume to ensure you don't have too high outflow. It takes up a lot of space, and it's hard to find place for that in dense urban areas. And it only removes suspended solids and, of course, the pollutants attached to suspended solids. We have a design criteria in Denmark on 250 to 300 cubic meters permanent wet volume per hectare paved catchment. And it's based on the graph in the top here, where in the bottom you have got you've got the relative volume of cubic meters of stormwater pond per hectare. So you have either 10, 100 or 1,000 cubic meters of stormwater permanent wet volume per hectare, and then the treatment efficiency on the other axis. And you can see, again, this is quite spread, but based on that, we have decided to work with these 250 to 300 cubic meters, as we don't see very big effect from making bigger volumes. I've been looking into filters and compact separators, and there are a lot of different types, like disc filters, hydrocyclone separators, and even separators with absorption unit, where you build in a unit with different absorption materials. The problem about these separators are they have a limited hydraulic capacity, and that means you need a lot of separators, or you need a detention volume before the separator, and that makes it quite an expensive solution. And then they have general low treatment efficiencies. But if you add adsorption units, you can have quite good efficiencies. But again, you need a lot of separators if you have bigger catchments. So they're not relevant in the cases we're working on, where our catchment might typically be from 10 to maybe 100 hectares. Then we've been working on this wet ponds with alum treatment, and the idea is that in the first well here on the left, we have a sedimentation chamber for bigger particles. In the next well, we have a measuring of the flow. And in the third well, we add alum chloride, and then we add sodium hydroxide to neutralize the acidity effect of the alum chloride. And then we mix it thoroughly into the water here, and then the next volume here would be like a reaction chamber where the alum chloride forms flux and thereby fixes phosphorus and metals. And from the reaction chamber, we flow directly into the sedimentation pond, which is like a traditional wet pond. And then in the outlet, we are measuring some parameters as well to ensure we don't have pH effects, etc. I would say it's a well-documented solution when it comes to wastewater, but on stormwater, it hasn't been proven as a solution yet. But we're establishing some 3 facilities like this, and we're going to do some extensive monitoring on the facilities when they are up and running. They have a large hydraulic capacity, as we can just add the amount of chemicals we need, and the chemical part of it requires quite limited space, but they're technical facilities, and it takes that we either have a filter or, in this case, a stormwater wet pond after the chemical treatment. And then as another advanced treatment option, we have sorption filters, and there are a lot of different sorption filters on the market. What we've been working on is a low-tech sorption filter. So what we do is combining sedimentation in a wet pond on your left here, and we dimension the wet pond as a normal wet pond to make sure we catch the particles here. And from the wet pond, the water flows into a filter here. And in the filter is made with a soil filter on the top with a vegetation to make sure we will ensure the infiltration capacity. And below the soil filter, we'll have a limestone filter where metals and phosphorus would adsorb quite efficiently. It takes, again, these 250 to 300 cubic meters of permanent wet volume in the pond, and then another 200 cubic meters of lime filter per paved hectare catchment. That's quite a big filter, but that ensures that we have a capacity for treating the stormwater over the next 50 years. The pros and cons are it's quite efficient in removing metals and phosphorus and particles, and it can be combined with the stormwater detention, as you can detain the stormwater on the top of the filter and the top of the wet pond. It's a low maintenance solution. You shouldn't, yeah, of course you should monitor on it once in a while, but it should work for about 50 years. The filter itself has a low hydraulic capacity, but you solve that with the detention volume, but it takes up a lot of space, which make it unsuitable for dense cities. Just to give you an impression of the typical concentrations we see in stormwater. In this case, we've been looking into open urban areas. We would have suspended solids like some 90 milligrams, 90,000 micrograms. We've got nitrogen and phosphorus, and then we have, in this case, BOD and some of the heavy metals. The wet pond has quite good removal efficiencies, but not sufficient to reach the environmental quality standards for our rivers and streams. So if we add alum treatment before the wet pond, we can get a better treatment efficiency. And if we have a wet pond with adsorption filter, we have similar or better efficiencies than the alum treatment. So if I should give some take-home messages from this, is that it's hard to set up valid typical concentrations for stormwater, but that we have to do it anyway to make our assessments. And the same consideration is for the treatment facilities. We have these data from meta studies, but they have a lot of older and maybe outdated data, so be aware of that. Apart from wet ponds, most treatment solutions are quite poorly documented. And treatment efficiencies, if you just use an efficiency like 80%, it depends on the concentration in the inlet, so it's not easy to make a true assessment on it. And then no matter what treatment we use, we don't solve the problem of reaching EU environmental quality standards in the recipients. If we've got a river with a huge flow, we'll have a lot of dilution of the stormwater, but the case in Denmark is that most of our streams are quite small. So when we have rain, we have stormwater as the main flow in the recipient, and that takes a very efficient treatment of the stormwater to meet the EQS goals. When we make the assessments, we use the data that we have, but in general, we try to qualify the data to try to reach the environmental quality standards. But when we do that using your data, you must make sure not to do cherry picking. It's very easy to reach your standards if you pick data from different sources, but you have to be fair when you use that. And then I have a plea in the end here. We need data, and I hope you'll all help generate data on stormwater and on treatment solution. And we have in Denmark, we have these regnvandskvalitet where we could report data, but it's I don't know if it's common in other countries, but that might be an idea for VSP to collect data from stormwater and stormwater treatment. Thank you.
Thank you, Søren, for that great and insightful presentation. So we have a couple questions in the chat. We can start with, what are the main sources of the pollutants,
pollutants,
that we find in the stormwater?
Yeah, it depends on pollutant. Actually, we made some calculations on stormwater from highways, and we measured the stormwater quality, and we measured atmospheric deposition as well. And if you look into copper, for instance, as a pollutant, we can see that about 90% of the copper in the stormwater actually comes from atmospheric deposition. That would be soil particles from the fields around settling on the surface and polluting the runoff from the road. If you look into zinc, as another case, atmospheric deposition only counts for about 10% of the zinc, where rest would be from tire wear and from zinc in materials, etc. So it depends on the substance. And that makes it difficult to reduce the substance load.
Perfect, thanks. Next one will be, can you point to other options at advanced treatment when we need to reduce the pollution load on the recipients?
Yes. We are working with some municipalities and utility companies to reduce the amount of stormwater, so there's less water to treat, and to reduce the load of pollutants into the stormwater. One example is that in most local planning in Denmark, it's mandatory not to use zinc and copper in downspouts and gullies. That reduces the zinc and copper load into the stormwater. That's like cleaner technology. Another thing is that we're working with some municipalities to reduce the paved area when they're developing new urban areas, and even reduce the paved area in existing cities. For instance, the municipality in Roskilde, which is just next to where I'm sitting here, they've got a goal in their wastewater plan to reduce the paved area by 1% per year over the next 25 years. And that way we reduce the amount of water, and that makes it easier to treat the stormwater. So there are a lot of possible ways to go, and cleaner technology is surely a way to go.
Thank you so much. So I got one here. So do you have experience or do you have experience or knowledge of floating wetlands in stormwater ponds and how they affect the treatment of both suspended solids as well as dissolved pollutants?
No, I don't have floating wetlands, but we've been establishing quite a few wetlands which are similar to floating wetlands, but made the other way around. So we've split the wet pond up in fractions by dams with plants on them, and the plants functions as traps for the particles, like the roots would function as traps for the particles with floating wetlands. And it seems to increase the efficiency of removal of particulate matter if you use that. You just have to make sure that there's not like a stream through the pond. So you have to ensure that all the water passes either over these dams with plants on them, or through these vegetated islands in wetlands.
Perfect, thank you. And thank you, Oscar, for your question. And last one that I have here, do you have experience with the costs of advanced treatment compared to sedimentation in the traditional stormwater ponds?
Yeah, we've made some calculations, and if you take for a 50 years lifespan, establishing the facility and operating the facility for 50 years, then I've made some calculations on a price per cubic meter, and a simple sedimentation pond would end up with a cost of, in Denmark, of 0.1 euro per cubic meter treated water. And when it comes to these what do you call them? These fixed filters, adsorption filters, we would end up about 0.4 to 0.5 euro per cubic meter treated water. And with alum treatment, we'll end up between 0.8 and 1 euro per cubic meter, which is quite a lot. It's similar to the cost to treat the water on a traditional wastewater treatment plant in Denmark. So it becomes quite a lot more expensive if you want to make advanced treatment.
Okay, of course. Thank you so much. Well, that's all questions that I have for now. Thank you, everyone, for your questions, for listening. And Søren, you can wrap up with a final message.
Thank you. But yeah, I haven't got anything here. Thank you for listening, and feel free to contact me if you've got questions, or if you want to suggest collaboration on anything.
Well, thank you so much.